So today we're going to be looking at different molecules and showing if they're going to be polar or nonpolar, going over Lewis structures and molecular geometry. So first of all, we start off with SO3. I've gone ahead and drawn out the Lewis structure right here. You can see it had 24 electrons to begin with. I took out 6 for the original 3 bonds, and then put on 6. We had 18 left over, so I could put on 6 for each one of the O's. Then the S had a violation on the octet rule, so I had to double bond one of the O's, which is really split. The bond is split between all of the O's. So this molecular geometry is going to be a trigonal planar, and since all of the domains are the same, it's going to be nonpolar, because each of them are going to pull out electronegativity the same amount. So that one's going to be nonpolar. For the next molecule, we have OF2, and this is the Lewis structure right here. It started out with 20 electrons and then took out 4 for the original bonds. With 16 left over, I took out 12 to put 6 on each fluorine, and then with the extra 4, you can throw them on that center O. And so all the octet stuff is fine. The molecular geometry is going to be tetrahedral bent because of these extra domains right here. And tetrahedral because there's 4 domains. So this one's going to be polar because with the molecular geometry being bent, it pulls on the sides for each of the fluorines. Alright, so the next molecule is going to be BeCl2, and here is the Lewis structure. Be is an exception. So it's actually fine having just 2 bonds and not having an octet. These CLs each have 6 on them, and this is going to be linear because there's only 2 domains on the center atom, and nonpolar because these CLs are going to pull out electronegativity in the same amount. So that's another nonpolar. So that's 2 nonpolars and 1 polar. Alright, so this next one is the CCl4. So the center atom's definitely going to be the carbon because it's the less electronegative. So we had 32 electrons to start out with, took out 8 for the original bonds, and then with 24 left, it makes it perfect to put 6 on each chlorine from there. So we have an octet on all of those. It's going to be a tetrahedral with the molecular geometry because it's got 4 domains out the center atom, and it's going to be nonpolar because all the domains are equal, and so they all pull out the same amount. So it's 3 nonpolar and 1 polar. And for the last molecule, we have O3. This one was a little trickier to draw, but it's basically just 3 O's in a line. Oops. It's one of these tears. Sorry about that. So started out with 18 and took out 4 for the original domains, and then with 14 left, you put 6 on here, and I did have 6 on here, but with only 2 left over after that, you have to double bond this to have the octet rule, which is really shared between both of them. So it's going to be, this one's going to be a trigonal planar bent too because of the 3rd domain on top of the center O. And that's going to be polar because with a bent domain, this one is always going to make sure that the atoms do not pull away from each other the perfect amount to make it nonpolar.